Welcome, this is a coding overview of sqrBEAT. Please watch the demonstration of sqrBEAT if you haven't already. So this is a debug program that I made in Objective-C to see the output of my audio processing code here. You can see we have all these parameters up here. So let's get this going. When I first started programming this, I only had text output to go by, which only really told me if things weren't crashing. Which was good up to a point, but I needed to see the output at some point. So I made this data visualizer to see the results of my code without having to go through my game engine first, which is Unity, and having to compile to that takes a really long time, so this is the fastest way to see what was going on. So this is the data for a song called 600 AD in Piano by kLuTz, which is on OC Remix. So here are the three sections of the data here. The top one is the raw frequency data. The middle one is the general volume of the song. You can see if it's bright green, that means it's loud. If it's darker, then not as loud. Red means it's generally below a certain threshold for starting notes. And then the bottom section is the final notes for gameplay. So let's start at the top here. The audio data is split up into chunks. So starting from the left here is the beginning of the song, and as it goes further right, it's farther into the song. So this audio data is split into small chunks, which are then split into frequencies. So each vertical line of this section here is a chunk, and they're all split into frequencies. Towards the top is the low end, the bass stuff, and as you go farther down, it's higher notes. That's just the way I did it, but kind of counterintuitive. So the bright white things here are notes. So you can see here with the beginning of the song, there's a single note here, a single higher note here, and then it starts getting into chords. And that's just what the raw frequency data looks like as we progress through the song here. So as we're looking at it, we can see that those are all distinct notes, but it's kind of hard for machines, in the code in this case, to differentiate what is a note or not. So the hard part of my code here is figuring out what should be a note and what shouldn't. So if we toggle on peaks here, the blue parts are continuations of notes and the red parts are generally beginnings of notes. So my code actually picked out that is a note there, that's a note there, and then starts picking out other stuff here. I wasn't really too concerned if it wasn't exactly getting them right, because it's generally correct most of the time. So I then put all this data into a container that holds all the peaks found in the song, and that's passed off to another coding section that ultimately makes the notes. So if we go down here to the notes, we can see here that my note generator takes quite a few inputs, like how loud a note has to be above the average to be considered a new note, or how loud it is in relation to the overall volume of the song, and that's all taken into account on whether or not a note should be started or continued or just completely disregarded in some cases. There's also thresholds for combining notes that are close together in time and placement. So we can see here that these two were likely part of the same notes, but the 8 probably got split off from the end of the other one, because I do have things to take into account. Like I don't want notes to be too long, as otherwise some songs could just be one single note, and that's no fun. So this likely would have been a single long note that was split into smaller sections here. There's also modifiers that I programmed in that can do things like randomize the placement of notes and also shorten notes to their minimum length. And of course this is only half of the coding puzzle. Once I had all the notes generated, I had to get them into the actual game, and that was no fun. The engine that I use is the Unity engine, which is great for making games in, but not so great for heavy calculations that I need to do while processing all this audio data. So all this processing code is done in the background in native Apple Objective-C and Objective-C++. And then the output is passed to the C# and .NET code that Unity runs on. This is no mean feat in and of itself. Then once Unity had the code, I had to synchronize the music with the note data. So you can see how this got very complex very quickly. So I hope this has been enlightening for you. Make sure to check out sqrBEAT on the App Store once it's released. Thanks for watching.